In this video, I'm going to try to prove the product rule. Now, similar to the chain rule is a really useful function where you are taking the differentiation of a function that looks like this. H of x is equal to f of g of x. So we've got these composite functions. Well, that's not a product, that's a composition of functions. What if instead h of x was equal to f of x times g of x? The multiplication between two functions. If you want to get an example just to kind of get your head around it, you could imagine you could have x to the 3 plus 3x times 5x to the 6 minus 2x. Right? Obviously you could just expand the brackets and go through, but as we're going to be introducing more complicated functions, we want to find a better way of taking the derivative of something that looks like this. So, let us go through it. Well, I know that if I just had a basic function, h of x, then the derivative h of x by first principles would be h of x plus h minus h of x all over h, and we're taking the limit as h goes to 0, right? Normally we do this with f of x, so we don't get with the double h's. Might make it look a little less ugly. Alrighty, so that's our basic one. Let's do the same thing for this h function on the left. So it's going to be the limit as h goes to 0, just like normal, but we're going to be doing f of x plus h, g of x plus h, minus f of x, g of x, all over h. Alrighty, now currently, if I have a look at this, there's nothing really to algebraically work with. So let's add something in and see what happens. Hopefully before my fan takes off. Alrighty, let's have a look. So we could flounder around for a while and think about what we could be adding in here. But in the end, you might eventually stumble across something like this. What if we then subtract f of x plus h, g of x? You might be wondering why we'd add that, or subtract that. Well, because we subtract something, we've got to add it back in anyway. You might be thinking, why would we add that? Well, the answer is that it helps us break this thing down into pieces we can actually manage. Meaning, I'm going to break it like this. I'm going to take this section here, and then I'm going to split it like this. So let's just look at the yellow bit for the minute. What does it have common factor-wise? Well, they both got a factor of f of x plus h. And this will be the good bit, because once I do this one, you might see the pattern for the next one. They take out f of x plus h. What am I left with? Well, g of x plus h minus g of x all over h. Well, heck, that looks really familiar, actually. Anyway, we'll come back to that in a second. Let's do it again, but now for the purple section, the pink section. So we're going to get plus, what's the common factor here? Well, we don't have a common factor of f of x plus h, we've actually got a common factor of g of x. So let's take out the common factor of g of x. What are we left with on the inside? F of x plus h, f of x all over h. Hey, this is looking not so bad. And the reason it's not looking so bad is that this is just the derivative of g. Well, after we take the limit as h goes to 0. And this is just the derivative of f. Well, same once you take h equal to 0. So let's now actually take the limit as h goes to 0. Well, as I said, let's take it term by term. So, the limit's being evaluated. F of x plus h, that goes to just f of x. Right? As h goes to 0, it just becomes f of x. G of f x plus h minus g of x over h, well, that's just, by first principles, that's just the derivative g dash of x. plus g of x, right? G of x has nothing to do with h, so when we take the limit, nothing happens to it. And this whole thing is just the derivative of f. So as h goes to 0, this becomes f dash of x. And we get the chain rule, which is that if you have a function that looks like two functions multiplied together, f of x times g of x, well, the derivative is just the first function times the derivative of the second plus the second function times the derivative of the first. That is the chain rule. Sorry, the product rule. And it is a very, very useful thing to be able to differentiate functions which are products. Alrighty, in the next lesson we're actually going to use it.